Welcome once again. I think we'll be going with the last session of program analysis. Okay, let's see what is there in. I think in the previous two sessions we have seen algorithms in flowchart. Here also we'll see almost the same thing, but we will see one more thing, that is trace. Now let's see what it is. Okay, so I just prepared some, I think, notes. So I think this program is to find sum of natural numbers from 1 to 10. So I just given an example. Now what will be the output of this? That is s is equal to 1 plus 2 plus 3 plus till 10. So because we want to find out the sum of all these numbers. I think those who are very quick in maths, they might be knowing that the output will be 55. Okay, so either you can do with this method, or I think you also have some formula, but let's do it with a long method. Okay, so you will be thinking that we require around 11 we require around 11 what do you call it, variables, but it's not like that. Let's start the algorithm. So start variable declaration. So we are having s and I. Can you see input? So we have to input two things, that is s is equal to 0 and I is equal to 1. We also call them as initialize. Okay, so we will be initializing like s is equal to 0 and I is equal to 1. Process is the next step. I think everyone knows that three steps are very important: input, process and output. So input we have done. Now let's process, repeat. Now can you see here, repeat means there will be a loop, that is while loop. So while I is less than or equal to 10. Now can you see I initial value is 1 is less than or equal to 10. If this is true, yeah, right now it is true because I is equal to 1 and they are telling you to I is less than or equal to 10. So you have to go to the fifth step. So directly we'll be going to the fifth step. If this condition becomes false, then you have to go to the sixth step. Okay, can you see go to 6? Now what do you mean by go to 6? 6 means this sixth step. And what do you mean by sixth, go to 5? That means you have to go to the fifth step. A fifth step is again a process. That means if this condition is satisfied, you have to do something. Now what you have to do is s is equal to s plus I and I is equal to I plus 1. Okay. Now right now you will not understand unless and until we go for the trace, and this will be repeated until this condition becomes false. Okay, if this condition becomes false, then only it will be coming to output s. Okay, then finally stop. Now whatever we have done, we'll try to understand through trace also. Now what do you mean by trace? That we will see within 1 or 2 minutes. Now I drawn the flowchart. Now when you see the flowchart, I think, can you see we have just repeated the same steps: start, variable declaration, input. I think everyone knows that for input you have to use parallelogram. So s is equal to 0, I is equal to 1. Then decision box is there because we have to check the condition. So whenever you check the condition, you have to take a decision box. I is less than or equal to 10. So if it is true, then s is equal to s plus I is equal to I plus 1. Either you can write with together also, or you can write separate boxes, but since they are in process, we have to use rectangle. So you have to use rectangle. S is equal to I and I is equal to I plus 1, and this will be continued till the condition becomes false. So this will continue, okay, till the condition becomes false. Once the condition becomes false, can you see yes, no? So yes means true and no means false. So since the condition is true, you have to execute these two steps and you have to repeat till this condition becomes true. And once it becomes false, you have to stop. That means you will not go inside this, and you have to go to the next step, number 6, that is output s. That means it will just print the sum, and finally you have to stop the flowchart. I think everyone knows that you have to stop somewhere. I think you easily understand, like start, variable declaration, input, then decision box, then you are having this process, if it is, what to do if it is true or yes, what to do if it is false or no. So if it is true, you have to repeat this. That's why can you see these lines? Okay, repetition lines are there. It will repeat again and again, and till the condition becomes false. Once it is false, then it will come here, and finally it will stop. So I hope you understood. Now I think this we have already seen in other two sessions. Now let's go with the very important session, trace. Trace means whatever you are done, whether these steps are correct or not. So can you see I is equal to I, S. Now what are these, from where they came? I think they are coming from the same algorithm or flowchart which we have used. So I is I is less than, can you see this is while condition. If this is true, then you have to execute these two steps. Okay, so initially can you see we have just initialized the value of I as 1 and S is equal to 0. Now it will check. Okay, it will check I is less than or equal to 10. Yes, can you see initial value of I is 1, 1 is less than 10. Yes, so if it is yes, then you can execute these two steps. Okay, now what is written here? S, what you have to understand on the top. Okay, what is written here? S is equal to S plus I. So S is equal to, what is the value of initial? Right now the value of S 0. What is the value of I? 1. So 0 plus 1 is 1. Then I is equal to I plus 1. So I is equal to I plus 1 means, what is the value of I right now? 1. And what is written in the instruction? Plus 1. So I is equal to I plus 1 plus 1, that becomes 2. So you can say that, just wait, the new value of I becomes 2 and the new value of S becomes 1 through the first step. Okay, now what happens, whatever these values are there which are marked will be used ahead. Okay, can you see I latest values, I's latest value becomes 2 and S latest value becomes 1. So now you have to use these values, not these, because these have been changed in the first step. Okay, and since this is true, you have to repeat the step. So what is the condition here? Condition will be same, steps will be same, but can you see I is less than 10? So since I is less than 10, what is the value of I, latest value? So you have to check the column, which column I am referring, I column. So you have to see the I value. I is less than 10, yes. So then S is equal to S plus S plus I. So what is the value of S? 1. 1 plus 2, 3. Okay, so now S becomes 3. Then let's go with I value, because since this is true, you have to execute both of these steps. So I is equal to what is the value of latest value of I? 2. 2 plus 1, because this is the step written, instruction written to us, that is I is equal to I plus 1. So 2 plus 1 is 3. Okay, then can you see the latest values of S and I becomes 3 and 3. I hope you are getting. I am not doing anything against the instructions. Whatever the instructions are mentioned, I am just following that. Okay, so 3 and 3 are the latest values of I and S. Okay, then what is this step? I is less than 10. So I, don't think of S. Whatever is written, you have to think about that. So I value is 3. 3 is less than 10, yes. Then S is equal to what are the latest values of S and I? Can you see S value is 3 and I value is 3. So the latest value of S becomes 6. Then, so I hope you understood how it becomes 6. Then I is equal to, can you see I is equal to I plus 1. What is the latest value of I? 3. 3 plus 1, 4. Okay, now you have to write these values which are marked here. Okay, at this columns, latest values of I and S. Okay, so I will become 4 and S will become 6, and this will continue. Can you see? It will check 4 is less than 10, yes. So now the latest value of S is 6, latest value of I is 4, so 6 plus 4, 10. Then latest value of 4 I is 4 and plus 1, that becomes 5. So this will continue. I think you can see that this will continue till let's go here. If the value of I becomes 10, so if the value of I becomes 10, and s becomes 45. Now what is written here is 10 is, what is the condition? 10 is less than 10, not possible, but it is equal to also. I think you can see it is written as equal to also. So this is true. Since it is true, you have to add this. So what are the latest values of s? 45. What is the latest value of I? 10. So this becomes 55. Okay, that is what we require, but we cannot stop here. We have to go ahead. I is equal to I plus 1. So what is the value of I now? 10. 10 plus 1, 11. So 11 is 11, and what is the value of s right now? 55. So latest value of I is 11. So 11 is neither less than or equal to 10. That's why you have to stop. Okay, no means stop, and when it stop, it will just print the value of s. I hope you understood. You have to, I think you will understand this algorithms and flowchart only when you will understand the, I think whatever the steps were written, I think the same steps I have written in the trace. Okay, I hope you got this. Now let's similar example, let's take the similar example. I think, can you see, to find the factorial of a given number? I hope you understand what do you mean by factorial. Factorial means 5 factorial is there. So what you will do, 5 into 4 into, so you have to repeat 3 into, okay, till 1. So that will become 120. 120 should be your answer. Okay, this is an example. You can take any other value and you can check. So but I hope you know what is factorial of a given number. So same, we are just writing the algorithm first. So start, we require only two variables, f and n. F stands for factorial, n stands for the given number. So f is equal to 1, and this is input. F is equal to 1 and n is equal to whatever the user wants, because the in the question it is written given number. So given number means the user requires. Then process. Now this is very important. Repeat while n is greater than or equal to 1. If this condition is true, you have to go to the fifth step, and if this is false, then you have to go to the sixth step. So I think fifth step is again will be a process. F is equal to f into n, and n is equal to n minus 1. Now can you see output, that is print the value of f and stop. Now don't worry, I think you will be thinking what are these steps and all, and how we'll get the answer. Now when we will take a trace, that time it will be more clear. But before we do it, we will be going with what you call flowchart. Now when we see the flowchart, I think that is also simple. Start, variable declaration, whatever the steps we have written in algorithm, f and n. Input, f is equal to 1 and n is equal to n. Now whatever the user wants, that the user can define, but it has to be greater than or equal to 1. So if it is greater than 1, then only it will be true. So if, like suppose if the value is 4, then this condition becomes true. So it will just calculate this and it will repeat till your condition becomes false. Okay, if it is false, it will just print the value of f and finally it will stop. So I hope, please draw the need diagrams. Okay, this is just for reference. Okay, so I hope you got this. Now whatever the steps have been written, let's try to understand. Now this is an example. Okay, value of, you will be thinking from where n is become 5. So we have taken, the user have taken, or I have taken the value of n is equal to 5. But this is true for all all the numbers, whichever the number you want to take. Okay, so f is equal to 1. I think that was the initial value of f we have declared. Then n is equal to 5. You just check the above conditions. N is greater than 1. Where is n here? So 5 is greater than 1. Yes. If it is yes, you have to execute these two steps. F is equal to f into n. So what is the value of f right now? 1. What is the value of n right now? 5. So 1 into 5 is 5. Then n is equal to n minus 1. So 5 minus 1, that becomes 4. So 5 minus 1, that becomes 4. So now can you see this value will you have to write these are the latest values which you are going to write here. Okay, so the latest values of what do you call uh, f and n are f becomes 5 and n becomes 4. Okay, now you have to continue, because since this is true you have to continue. Now what is written here? N is greater than 1. What is the value of n? 4. 4 is greater than 1. True. Now can you see f is equal to f into 4. So value of f is 5 and value of n is 4. So 4 into 5 is 20. Now can you see n is equal to 4 minus 1, that becomes 3. So the latest value of n becomes 3 and f becomes 20. Again we have to continue. Now since we will continue here, can you see you will be getting 5, 40, 20, 60, 120. Now what happens when n is 1? So can you see n becomes 1 and f becomes 120. So n is greater than or equal to 1. Yes, it is not greater than, but it is equal to. So again we will be doing this. So 1 into 120 is 120 only. Then can you see it becomes 0. So the latest value of n becomes 0 and f becomes 120. Now when n becomes 0, n is neither greater than nor equal to 0. So we have to stop. Since we stop, you have to end the algorithm or the flowchart. So I hope you understood. Same thing, we have just taken one more example to find GCD of two numbers. I think this you can do with many examples, but I have taken a very simple one. Start, variable declaration. So we have to take only two variables. I think everyone knows greatest common divisors that we are finding. Okay, then input a and b, because we require GCD of only two numbers. So process repeat while a is not equal to. Okay, this sign it is written as not equal to. Okay, not equal to b. If this is true, go to step number 5, else go to step number 6. Now when you go to step number 5, can you see again we are having conditions. If a is greater than b, a is equal to a minus b. If b is greater than a, b is equal to b minus a. You will be thinking what it is and how we will be getting this output. Don't worry, when we'll go to the step number 6, can you see GCD equal to either a or b. Now you can stop the algorithm. Now let's draw the flowchart. Now flowchart is little messy, but just concentrate. Okay, start, variable declaration a and b, then input a, b. Then can you see here a is, if a is not equal to b, a is not equal to b, if it is true, then you have to again go to the condition. A is greater than b. If a is greater than b, you have to a minus b. Okay, you have to do that. Then b is equal to, if b is greater than a, b minus a. But I think in this flowchart one small error is there, that is you have to link this to this repeat sign. Okay, so you can link it to this, otherwise this algorithm, if this is, it will not come back. If the control, if you don't draw this line, it should come to here or somewhere. Okay, so it will not come back. After processing where to go, it is given like this. So this has to be linked. Okay, now if a is greater than b, then you have to subtract a minus b. If b is greater than a, you have to subtract b minus a. Now this will continue till the condition becomes true. If it becomes false, output is either a or b, and stop. You will be thinking how either a or b can be the output. Okay, so let's take a trace. Unless and until we go for the trace, we will not understand. So let's go for the trace. Now when you go to the trace, think I have taken two traces. Trace number 1, if the value of a is 30 and the value of b is 10, I have just assumed this values, then can you see both are not equal? 30 is not equal to 10. This is true. Since it is true, we have to execute all these steps, whatever is written. Okay. Now, if A is greater than B, yes, 30 is greater than 10. So this is true. Since this is true, we have to execute A is equal to A minus B. Okay. So what is the value of A? 30. What is the value of B? 10. So the latest value of A becomes 20. Okay, then it will go here. If B is greater than A, it's not possible because B value is 10 only, so false. And then if it is false, we will not execute this, we'll directly come to this step. So the latest value of A is what? 20. That's why I have written here. Now the value of A becomes 20, value of 10, value of B is same, that is 10. Now again it will check. A is equal to B. A is not equal to B. Yes. Since it is true, it will come and check this condition. What is written? A is greater than B. Yes. What is A value? Latest value 20. What is B value? 10. So this is true because A is greater than B. Then again you have to subtract A minus B. It will come here. It will check. B is greater than A. Not possible because B value is 10 and A's value is also 10. So 10 cannot be greater than 10. 10 is equal to 10. Okay, it will not execute. Now can you see here latest value of A becomes 10 and value of B is also 10. But what is written here? A is not equal to B, but this is equal to B. A and B are equal. So since A and B are equal, you have to stop, and GCD is 10. That means either you can write the value of A, this is GCD is equal to A, or GCD is equal to B. Either of the values you can write, but not both. I hope you got this. We'll take one more example. That's why I've taken a new trace. I think trace number 2. Here we have taken two values that is 30 and 7. I think everyone understood that GCD is 1. So let's try how you got this one. So 30 and 7 are not equal. This is true. Then A is greater than B. Yes, because 30 is greater than 7. So you have to subtract. So A latest value becomes 23. This is false. This is since this is false, you cannot do you cannot do anything here. Then A value is 23 and 7. These are the latest values, both are not equal. Then again this is true. Then A is greater than B. Yes, because 23 is greater than 7. So 23 minus 7, that becomes 16. This will be false only, so you don't have to go through this. Then the latest value of A becomes 16 and B is 7 only. So since they are both not equal, so this is true. Then you have to again subtract. So 16 minus 7 becomes 9. So this will be false. So now let's see here, 7 minus, so this is 9 and 7. So this will become 2 here. Now can you see, now the latest value of A becomes 2 and the value of B is 7 only. Now what happens in this case? Can you see this is not equal, but this is false because here B is greater. Since B is greater, this will become true. And can you see now the B value will get updated. When B value is updated, can you see B becomes 5. Okay, so it will again, A and B are not equal, true. This is false, this is true because B is greater, so subtract. Okay, since we subtract, 5 minus 2 becomes 3. B value is updated. Again B is greater, so we have to come here, B becomes 1. Now can you see, now in this case B becomes 1, that means A is greater. A is greater, so both are not equal. A is greater than B. Yes, so you have to subtract and update the value of A. So here you cannot go because both are becomes equal. Now since both are equal, you have to stop this algorithm or stop the flowchart or the trace. So can you see, we have to stop it here, and once you stop, can you see GCD is 1. Either you can write value of A or value of B. I hope you understood. What was the new thing here was I think whatever I explained you, that is through trace. Now trace will give you a way to find whether you are going in the right direction or wrong direction, because these are the steps and when you will execute on paper, or when you execute uh, before you execute, if you check your program, I think that is one of the best thing to do it. If your trace is wrong, that means you can say that something is wrong in your, either in algorithm or in flowchart. And remember that algorithm is the main thing, because if your algorithm is wrong, then your flowchart will also be wrong and your trace will also get wrong. So I hope you understood all this algorithms and flowchart. So please practice this by taking any examples, and just try to draw what do you call it, write the algorithm, draw the flowchart and trace. So thank you, we'll meet in the next lecture.